Hey everybody, today we're going to learn about sedimentary rocks and we're going to focus on this reference chart which classifies the rocks into three major groups. Inorganic, which is up here, and then chemically formed sedimentary rocks or organically formed sedimentary rocks. So first we're going to go over the definition of the three groups. So first major one is clastic. And clastic literally means fragments. So this means a sedimentary rock that is made up of fragments. So the word itself is the definition. And how you get this, you can look back in the rock cycle diagram. So it forms when rock fragments, which are also known as sediments, get deposited, buried, and then compacted and cemented together. And compacted and cemented, we call that collectively the process of lithification, which means the act of becoming a sedimentary rock, to lithify, to become land. All right, that's really what that means. Some of the well-known examples of a clastic rock are shale, sandstone, and a conglomerate. And we'll look at all of them in a chart and images of them. All right, now a rock can also form chemically. So a chemical sedimentary rock forms when dissolved minerals precipitate means to fall out of solution, or from seawater evaporating, leaving the dissolved minerals behind. So for example, if there's a lot of salt in the ocean, which there is, and the ocean evaporates, it's going to leave that salt behind, a big pile of salt. We would call that rock salt. Okay, and some other ones that are formed chemically is rock gypsum and chemical limestone. The last major rock group that make up sedimentary rocks are organically formed. Well, organic means from a living thing. So if you have a lot of crushed up seashells and they get compacted and cemented together, then they will form what's called organic limestone. Or you can have lots of plant remains that are pressed together, and that's what we refer to as coal. So coal and organic limestone are the two major kinds of organically formed sedimentary rocks. Okay. So here's the chart to classify clastic. And even the term clastic is defined in this chart. See right here? Fragmental. So there's different size fragments. The smallest size is known as clay. So if clay gets compacted and cemented together, then it forms shale. Now let's say the sediment was a little bigger than clay. Then we refer to it as silt. And if silt gets compacted and cemented together, we call it siltstone. Now if it's bigger than silt, but smaller than a pebble, that's what we mean by sand. So if sand gets compacted and cemented together, we call it sandstone. Now you might be thinking to yourself, why don't we call shale claystone? I have no idea. Right? We call silt siltstone, sand sandstone. Why don't we call clay claystone? We call it shale. All right? Now if there's a pebble at all present in the rock, or anything larger than sand, so that means it could be a mixture of different sizes. That's what we refer to as a conglomerate. But look under comments, but only if the sediment is round. So if it's all these different sizes and the sediment is sharp angles, then we call it a breccia. Right. So here's the appearance, a few of them. So we have right here is shale. That's the first one on the picture. Now, those white impressions, that's fern fossils. Shale preserves the best fossils because all it really is hardened mud. And if something falls in mud, it will leave an impression. So shale usually has your best fossils. So here's the next one up. We call it siltstone. So if the clay got a little larger, it's now called silt. And the stone's called siltstone. If silt was a little larger, then it's called sand. And you get sandstone. And what you're seeing there are the different layers of sand that were burying the previous layer. So sedimentary rocks are usually layered as well. And then the next rock, see that big pebble right here? So if there's a pebble at all, and it's rounded, that's called a conglomerate. Let me clear this. Okay. Now we're going to go over the organically formed and the chemically formed sedimentary rocks. So let's start with the organic. So here is a black shiny rock with layers. It kind of looks just like this image under the map symbol. And this is coal. Now you can't really see under comments, the plant remains. All right. So this might be a little challenging for you to identify. But if I asked you a question about coal and how it forms, you could just look under comments and tell me, oh, coal forms from compacted plant remains. Now, the texture of coal, since it's from plant remains, well, plants were once alive. That's what bio means. Bio means life. And we already went over that clastic means fragments. So right here, they're telling you it's made up of life fragments. In this case, the life fragments are plant remains. All right, this next rock, which kind of looks like a granola bar, is really thousands of seashells compressed or compacted together. All right, and this is organic limestone, or a type of limestone called coquina. There's actually two types of ways limestone can form. So once again, if you go over the comments and limestone, it gives you the two ways. See, it says precipitates of biologic origin, but then there's an or cemented shell fragments. So this is the cemented shell fragments portion of the sedimentary rock. So this one would also be bioclastic. It doesn't look crystalline, right? And you would know immediately that it's limestone because it has calcite. So if you remember, it should bubble with acid immediately. So if you took acid on this rock, put a drop on it, it will bubble up, it will fizz. Okay. The next rock. See, this one kind of looks like a crystal. That's why the texture would be crystalline. All right. So if it looks like a crystal, then it most likely formed from seawater. That seawater had to evaporate. All right. Or there was so much salt in the water that it precipitated out. And yes, this one is salt. It's see the pink. Some of you might have this one at home. It's the Himalayan pink salt, right? Just like diamonds can be different color, salt can come in many colors. Remember, you should never go by color. So this is rock salt. And they actually tell you right here how it forms. Crystals from chemical precipitates. So if the seawater was rich in halite, you would get rock salt. But if the seawater was rich in gypsum, then you would get rock gypsum. If it was rich in dolomite, then you would get dolostone. And that's how you use this chart. Okay. Let me erase this. And that's rock salt. So I just want to go over two last points. So sedimentary rocks are the most common rocks on the surface. They actually make up 75% of the surface, which means you're most likely going to walk on sedimentary rocks. However, if you start to dig down into the earth, they disappear. See, they only make up 5% of the entire crust. See, The top one is the surface. The bottom pie chart is the entire crust. So that's strange. 75% of the rocks you're likely to walk on are sedimentary, but once you dig down, they disappear. The reason that happens is the next question I have. So why are sedimentary rocks so common on the surface? So why do we find them on the surface but not deep down? And it's a simple answer. Guess where the only places are that you can form sediments? The surface. You can't have the processes of weathering and erosion and deposition happening deep under the ground. So since the processes that form sedimentary rock occur on the surface, then you're only going to get sedimentary rocks on the surface. That's the answer. So once you start digging down, that's when you hit your igneous and metamorphic. All right, the last concept that I really want to go over with this group of rocks is, see this picture here? Those are fossils. So even though you don't have that rock in your hand, once you see a fossil, you know that rock is sedimentary. All right? Fossils cannot form in metamorphic rocks because the heat and pressure will destroy the fossil. Also, fossils can never form in igneous rocks because igneous rocks come from magma or lava. And magma and lava, nothing can live in it, right? If something falls in magma and lava, it is now magma or lava. So you can only, if you find a fossil, you know immediately that it is a sedimentary rock. But first, what is a fossil? It's any preserved form of life, preserved remains of life. What's the only type of rock that can have a fossil? Sedimentary, because heat and pressure associated with igneous and metamorphic will destroy any organic remains. Okay? And here is steps of a fossil forming. So a dinosaur died and fell onto the sand. It left its footprints and its skeleton. But then over time, the sea level rose and buried it with sand. And then water dissolved minerals in the water kind of replaced the minerals in the bone. And it created a fossil. All right? That's another reason why you can only have fossils in sedimentary rocks, because if something dies, it eventually has to get buried. It can only get buried by sediment. So that's another reason why you're only going to have fossils in sedimentary rocks. All right, that's it for today. As always, if you have questions, email me, ask at the Google Meet. All right, subscribe to my channel. Give me the thumbs up. Have a good day.